Okay, so this lesson focuses on solving square root equations in which the solutions or the roots are rational. So we're going to be dealing with just rational solutions in this case. And before we get started on solving square root equations, let's review an idea that's going to be needed for this. So if you're asked to find the square root of 25, and you want to find out what the square root of 25 is, you're asking yourself, whatever number you put here, that number times itself will be 25. So what number times itself is the radicand 25? And so you'd say 5. So the square root of 25 is 5 because 5 times 5 is 25. Same thing for this. If you had the square root of 49, you would ask yourself, what number times itself is 49? Okay, so what number times itself is 49? So you'd have to say 7. So 7 times 7 is 49. Okay, now you may also say this. You may say, negative 5 times negative 5 is also 25. But remember, we are dealing with and this is, see this positive square root right here? We are dealing with the principal square root. Okay, so if I wanted this to be a negative 5, I'd have to have a negative out in front. Okay, so don't make it any more complicated than it is. That's all you're dealing with, is what number times itself, what positive number times itself is 25. So the positive square root of 25 is 5. The positive square root of 49 is 7. If you had this, then you would say negative 5, because square root of 25 is 5, and so then I want this to be a negative 5. All right, so don't make it any more complicated than it is. This is really all you need to know for what we're about to do. Okay, so let's suppose you want to solve each of the following square root equations. We're going to start out with a simple one. And so let's say I had the square root of x equal 4. Square root of x equal 4. And so remember what we did was here. What we did here was this. We said 5 times 5 is 25. 7 times 7 is 49. And so I want to find out the square root of what number is 4. Well, 4 times 4 is 16. So you would think that x would have to be 16. Okay, so remember you're solving this equation, so meaning you're solving for the variable, in this case, the variable x. And so if you think about it, if you think about this, is the square root of 16 equal to 4? And the answer is yes. 4 times 4 is 16. So that's the idea. So now there's a procedure you're going to use. It's not going to be this simple. So there is a procedure you're going to have to use. Now, here's the procedure. So here we guessed at the answer because it was a very simple problem to guess at the answer. 4 times 4 is 16. But I want you to think about this in a different way. So if I go back to this problem right here, the square root of x equal 4, and we're going to solve this algebraically. So we're going to solve algebraically rather than guessing at the answer. Solve algebraically. Okay, so when solving a square root equation, and for us it's only going to involve one square root expression. There are situations where you'll be solving square root equation. There could be 2 radicals in it. For us right now, for this particular lesson, you're only dealing with 1. So to solve these algebraically, the first step you're going to do is you're going to isolate the radical. Isolate the radical. In other words, get the radical by itself. Get the square root by itself. In this case, it already is. The square root expression is already by itself. So you brought everything else to the other side. Everything else is on the other side. Okay, now, look at what you're doing. I'm trying to get x by itself. Right now, I'm taking the square root of x. The opposite of taking the square root of x is to square both sides. So step 2 is to square both sides. Now, remember, you're squaring only because we're dealing with square root equations. So see, the index is 2. If this index was cube root, if that was a 3, the opposite of cube rooting is to cube. So we'd raise both sides to the 3rd power. But all we're dealing with here is square root equations. So you'd square both sides. So I'm going to rewrite this problem. So I get square root of x equal 4. I'm going to square both sides, just like that. And remember, based on previous experience, see this right here, the square root of x times itself, because it's being squared. Square root of x and square root of x. Remember, that's the square root of x squared, which is x. Okay. And sometimes you'll hear people say the square root and the square are inverses, so they undo each other. So you're just left with x. And so notice on this side, you get 4 times 4, which is 16. And so there's your answer. So that's solving the equation algebraically. Now there's one more little step. Well, step 3 would be to solve for the variable. And that's what we did here. And that would be one more step you're going to have to do, and we'll come back to that when we get to it. All right, so that's number 1. So number 1 was simple enough to where since the index is 2, since I'm squaring, you're going to square both sides. Since I'm square rooting, you're going to square both sides. Okay, now number 2, let's suppose this was number 2. We had the square root of x minus 1 equal 3. The square root of x minus 1 equal 3. Okay, so you can probably guess at this as well, because you're asking, see how the square root's by itself, and that's what you wanted? You would isolate the radical, what's already by itself. Well, think about this. Remember, you're taking the square root of x minus 1, this expression. All right, so what number times, well, you take this number, so 3 times 3 is 9, okay? So this right here has to be 9, all right? And so if this right here has to be 9, then what must x be? Well, x must be 10, because 10 minus 1 is 9. All right, so some of these you can guess at, but we're going to do this algebraically because many of you probably could not have seen that x would have to be 10. All right, remember, 3 times 3 is 9, so this right here has to be 9. This radicand has to be 9. So meaning x minus 1 has to be 9, which means x has to be 10 if you add 1 to both sides. Okay, but let's just look at this. So first step is to square, the next step is to square both sides. So I'm going to rewrite this over. I'm going to square both sides. Okay, and remember this idea right here, the square root of x minus 1 times the square root of x minus 1 is just the radicand. So the square and the square root undo each other. So you get x minus 1 equal 9. Remember, that's what we had here. See this? And so you add 1 to both sides, and so you get x to be 10. Okay? Now let's go ahead and just check this to make sure it's correct. All right, so always check. So if I check this, you go back to the original problem. I'm saying x is 10. So I'm looking at the square root of x minus 1 equal 3. So is the square root of 10 minus 1 equal to 3? That's the question. And so if you look at this, the square root 10 minus 1 is 9, and the square root of 9 is indeed equal to 3. All right, so that's number 2. Okay, number 3, let's suppose in number 3 you had this. Number 3. Suppose in number 3 you had the square root of 3x plus 1 minus 3 equal 7. The square root of 3x plus 1 minus 3 equals 7. Okay, now this one's a little bit more difficult now because if you look at it, you don't have the square root by itself. You have this extra term right here. So remember, the first thing you have to do, the first step, is to isolate the variable, meaning to get isolate the radical, meaning to get the square root by itself, the square root expression by itself. So the first thing you're going to do is you're going to add 3 to both sides. So I'm going to add 3 to both sides. And so I get the square root of 3x plus 1 is equal to 10. Square root of 3x plus 1 equal 10. Okay? Now, again, before you square both sides, you have to make sure that the square root is by itself. All right? So now I'm going to rewrite this, and I'm going to square both sides. So I get 3x plus 1, it's equal to 10, and I'm going to square both sides. And so the square and the square root undo each other. So basically, if you said 3x plus 1 times 3x plus, times the square root of 3x plus 1, rather, then that's just going to be 3x plus 1. That's all that's going to equal. And so you get 3x plus 1 equal 100. And then you just solve for the variable x. So I'm going to subtract 1 from both sides. And so I get 3x equal 99. And then I'm going to divide both sides by 3. And so I get x to be 33. So that's what I get x to be. All right, let's check it. And always go back to the original problem to check. So I'm going to rewrite the original problem. So I have the square root of 3x plus 1 minus 3 equal 7. All right, so in place of the variable x, I'm going to substitute 33. So I get the square root of 3 times 33 plus 1 minus 3 equals 7. That's what I want to see that's equal to. Well, 3 times 33 is 99. And so I have the square root of 99 plus 1 minus 3. Well, the 99 plus 1 is 100. So I have the square root of 100 minus 3. The square root of 100 is 10. This is 10. So 10 minus 3 is indeed equal to 7. All right, so this is correct. Number 4, you have the square root of x plus 4 is equal to 0. The square root of x plus 4 is equal to 0. All right, now let's look at this particular one. All right, so the same idea, you're gonna get the radical expression by itself. You can get the square root by itself. So I need to subtract 4 from both sides, just like that. And so when I combine like terms, I get the square root of x is equal to negative 4. Okay, now let's just go ahead and continue on with the algebraic procedure. So I'm going to go ahead and square both sides. So we're going to square both sides. So I get the square root of x equal negative 4. I'm going to square both sides. And so when I square both sides, then I'm just going to get this radicand right here. Square root of x squared is just x. And then negative 4 times itself, negative 4 times itself is 16. Okay? All right, now let's check this. Okay, let's check. So I'm going to go back to the original problem. Here's my original problem. Okay, that was the original. And so in place of the variable x, I'm going to substitute 16. So I get the square root of 16 plus 4 equals 0. That's what I'm looking to see if that's equal to. Well, the square root of 16 is 4, but 4 plus 4 does not equal 0. 4 plus 4 is 8. So then you got to think about this. Well, why is 16 not working? Why is 16 not a solution? Well, let's go back to this one right here. This right here. And remember we said this. We said that this, well, let's go back over here. We said that when we take the square root of 25, again, we're looking at the positive square root here, positive square root. When you're looking at the square root of 25, we get a positive 5. Remember, we didn't say negative 5, okay? Not negative 5, we said 5. The square root of 49 is a positive 7. The square root of 25 is a positive 5, okay? So here, you have the square root of x, the positive square root of x is negative 4. Well, this right here has to always be positive. See this right here, you're looking at the positive square root. So that has to be positive. So that's why it doesn't work. See, the square root of 6, the square root of whatever positive number you put in here, or 0, is never going to be negative. It's always going to be positive. So one of the things you got to remember is that if you have the square root of an expression, and that's equal to a positive number, okay? Well, I'm sorry, negative number, you're going to say no solution. So this right here has no solution. This equation right here has no solution. All right, so because when I solved this and I got x to be 16, it didn't work because the square root of 16 is 4. 4 plus 4 is 8. It's not 0. All right, so what happens is this. When you square both sides, sometimes you introduce extraneous solutions. So we're going to write the word extraneous solutions. E-X-T-R-A-N-E-O-U-S, extraneous solutions. So sometimes we'll just call them false solutions. So when I square both sides, I get x to be 16, but it's not a solution to the original problem. Okay, so that's a false solution, it's an extraneous solution. All right, now number 5. Okay, number 5, suppose we had this. We had the square root of 12 minus x, square root of 12 minus x, equal x. All right, now this is a situation where we're going to have variables on both sides. So here, when I solve problems 3 and 4, well, let's say 3 for right now. 3, when I solved 3, I got on this side just the number. Now, if you look at this, I have a square root by itself, so the square root expression is already isolated, but I have a variable here. All right, so still the same process. You're going to square both sides. So I'm going to have 12 minus x equal x. So if I square both sides, and again, remember the square and the square undo each other, so you get 12 minus x here, equal, and then x times x is x squared. Okay, now notice that this equation is a quadratic. Okay, so you need to solve this quadratic equation. Now to solve this quadratic equation, you got to first of all write it in standard form. So since x squared is positive over here, I'm just going to bring everything else to this side. So when I rewrite this in standard form, so remember standard form, you have to have 0 on the other side. So ax squared plus bx plus c equals 0. So that's standard form. So when I rewrite this, I get x squared, and then I'm going to subtract 12 from both sides, just like this. And so I get x squared minus 12, and then again, you're going to add x, so again, plus x, oops. And let's just put it in descending order. So I get x squared plus x minus 12 equals 0. Okay? Now, for the most part, these are going to be factorable. So all of these, remember we talked about the solutions being rational. So the solutions are rational. That means that these quadratic equations are going to be factorable. So I'm going to go ahead and factor this. And so when I factor this, the factors that will work will be 4, 3, and then this will be 4, this will be minus. All right, so again, always check. The outer is negative 3x, the inner is 4x, and when you add them up, you get x. Positive 4 times a negative 3 is a negative 12. And then we're going to use a zero factor property, so you're going to set each of these equal to 0. So you get x plus 4 equals 0, x minus 3 equals 0. And so when you solve for x, you get x to be a negative 4 and x to be 3. All right, now this time you have two solutions, so let's check them. Let's check these. So let's check 3 first. So if I check 3, I'll go back to the original. So I have the square root of 12 minus x equal x. So wherever we see the variable x, I'm going to plug in 3. So I get the square root of 12 minus 3, and I want to see if that's going to equal to x, which is 3. Well, let's check this right here. 12 minus 3 is 9, and what's the square root of 9? Well, the square root of 9 is equal to 3. So 3 is a solution. So that is a solution. Now let's check negative 4. Negative 4. So check x equal negative 4. So again, you go back to the original. So I'm going to rewrite it. 12 minus x equal x. So in place of x, I'm going to substitute negative 4. So I get the square root of 12 minus a negative 4. And I want to see if that's going to equal a negative 4. Well, 12 subtracting negative 4 is 12 plus 4, which is 16. And the question is the square root of 16 equal to negative 4? No, because the square root of 16 is equal to a positive 4, and 4 does not equal negative 4. So this is not a solution. Negative 4 is not a solution to the original problem. So remember, negative 4 is a solution to this quadratic. So it is a solution to this, but it's not a solution to the original, because when we check it, the left side does not equal the right side. So remember the idea that the extraneous solution. So negative 4 would be considered an extraneous solution. So negative 4 would be called an extraneous solution or extraneous root. So in the blank where they have the word solution, you would say x equal 3. That's the only solution. Okay. All right. So that was number 5. So remember the steps. You isolate the variable, you isolate the radical, which is already by itself. You square both sides, In this case, you end up with a quadratic equation. You have to put it in standard form, and then these are going to be factorable, and so you just solve, and you remember you got to check, because sometimes you do get extraneous solutions. Okay, number 6. All right, number 6, suppose we had this. Suppose we had, so we're doing a similar, we'll do another one just like number 5. So number 6, suppose you had the square root of 9x minus 14 equal x. Square root of 9x minus 14 equal x. So again, step 1, remember, is to get the radical by itself, which it already is. So then I'm going to square both sides. So I'm going to go ahead and rewrite this over. And I'm going to square both sides. And so the square and the square root undo each other. And so you get the radic hand. And then this side you get x times x, which is x squared. Okay, so now we ended up with a quadratic equation. So I'm going to go ahead and put this in standard form. So I'm going to put this in standard form. And so since x squared is positive, so the coefficient here is positive on this side, I'm going to bring everything else to this side. So I'm going to put in descending order. When I do that, I get x squared minus 9x plus 14 equal 0. So that's what you get. X squared minus 9x plus 14 equals 0. And remember to say these are going to be factorable, so I'm going to go ahead and factor this. So x, and the factor would be 7 and 2, and then they're both x, and they're both negatives, the terms on this side. All right, then I'm going to set each one equal to 0. So you got x minus 7 equals 0, x minus 2 equals 0. And so when I solve these two equations, I get x to be 7, x to be 2. All right, now again, you got to check. So let's check these. So let's check both of them. So x to be 7, because remember you have to check for extraneous solutions. Both one of these could be false solutions, or they could both be false solutions for that matter. So x equals 7. So that's the other step that some people forget to do. Once they get to this, they forget to check for extraneous roots. All right, so the extraneous roots are not going to be solutions. They're solutions to this quadratic, but they're not solutions to the original square root equation. See, these are two different equations. This is a quadratic equation. This is a square root equation, a radical equation. So if I check x to be 7, go back to the original. So here's the original. Minus 14. And we'll see if that's going to equal x. So I get the square root of 9 times 7 minus 14 equal 7. So wherever I saw the variable x, I substituted 7. Well, 9 times 7 is 63. And so 63 minus 14. Again, you want to see that's going to equal 7. 63 minus 14 is 49. And so the square root of 49 is indeed equal to 7. So 7 works. So that's a solution. So 7 is a solution. Now let's check 2. So we check x equal 2. So I get the square root of 9 times 2 minus 14, and we're going to see if that's going to equal 2. Well, 9 times 2 is 18, and 18 minus 14 is 4, and the square root of 4 is indeed equal to 2. So 2 is also a solution. Okay, so 2 is a solution in this case. So here we have two solutions. All right, so when you're solving square root equations, you got to check for extraneous solutions. So notice that when I did this one, I only ended up with one solution. This one was extraneous, so that's one solution. That was a false solution. So that was a solution. Remember, both of these are solutions to this quadratic, but they may or may not be solutions to the square root equation. So you have to check. You are going to have to check. So this had one of them. Here, both of them worked. So both of them were solutions. So you do have to check them. Okay, number 7. Let's look at number 7. Number 7, suppose we had this equation. So suppose I had the square root of 2 minus x plus 3 equal x plus 7. So the square root of 2 minus x plus 3 equal x plus 7. Now this is going to be becoming a little bit more complicated. And you're going to see in the process why this is a little bit more complicated than the other one. But it's doable. You just have a few more issues to deal with. Okay, so remember, you got to get the radical by itself. So I got to subtract 3 from both sides. And I'm going to combine like terms. So this is 0. So I get the square root of 2 minus x equal. And then those, when I combine those 3 terms, when I simplify this expression, this will be x plus 4. All right. Now, just like before, the next step is to square both sides. I'm going to rewrite this over. I'm going to square both sides, just like this. You got to square both sides. All right, so notice this is a binomial, so put that in parentheses and then square it. So make sure you do that. The square and the square root into each other, so you get 2 minus x equal. Now let's go off to the side and figure out what x plus 4 times itself is. So x plus 4 times itself. So when I FOIL this, I get x squared. The outer is 4x. The inner is also 4x, so I get 8x. And then the last, 4 times 4 is 16. So this right here is this. So I get x squared plus 8x plus 16. Okay? Now, if I compare this right here, this with the previous problem, see the previous problem on this side, there was only one term. See, there was only one term here. Over here, there were 2 terms. So when I square both sides, I ended up with just still one term. And then that was easy to get the quadratic in standard form. Here, though, when I square both sides, I get a trinomial. But you still want to put it in standard form. It still has to be in standard form. All right, so again, the coefficient of x squared here is positive, so I'm going to bring these terms to the side. So if you need to do it in steps, do it in steps. The first thing I'm going to do is I'm going to add x to both sides and align my like terms. So I'm aligning my like terms. And so I get 2 equals x squared plus, this is plus x right here, plus 9x plus 16. And then I'm going to subtract 2 from both sides. And again, I'm aligning my like terms. I'm putting them together. So they get 0, which is what I wanted. Remember, ax squared plus bx plus c equals 0. So I need 0 on one side. Equal x squared plus 9x plus 14. Okay? All right. Now I'm just going to go ahead and transpose both sides. So I'm just going to rewrite this as x squared plus 9x plus 14 equals 0. Okay, now I'm going to factor. So remember, these are going to be factorable. So what's going to work here will be 7 and 2, and then both positives. So x plus 7, x plus 2 are your 2 factors. All right, so I'm going to solve this equation here. I'm going to set both factors equal 0. When I do that, I get x plus 7 equals 0, x plus 2 equals 0. And so I get x to be a negative 7 and x to be a negative 2. Okay? Now remember, these two solutions, these two are solutions to this quadratic equation. But remember, we are solving a square root equation, so you got to go back to the original problem and make sure it works. Because you got to check for extraneous solutions. You have to check for extraneous solutions. Okay, extraneous solutions. All right, so let's check the first one. We're going to check x equal negative 7. All right, so we write the original problem. So here's the original problem. It was the square root of 2 minus x plus 3 equal x plus 7. All right. Now, so wherever I see the variable x, I'm going to substitute negative 7. Now, you got to be careful with your subtractions. So this becomes the square root of 2 subtract x, and x is a negative 7. So 2 subtract a negative 7 plus 3 and I want to see if that's going to equal negative 7 plus 7. That's what I want to see if that's going to equal. Well, first of all, 2 subtract a negative 7 is 2 plus 7, which is 9. So the square root of 9 plus 3. And on this side, negative 7 plus 7 is 0. Okay? Well, the square root of 9 is 3, and the question is 3 plus 3 equal to 0? And the answer is no. So negative 7 is an extraneous root. So that's not a solution to the original equation. Now let's check negative 2. Okay, so let's check negative 2. So when I check x equal negative 2, I'll go back to the original equation, which is this. So that was the original. And where we see the variable x, I'm going to substitute negative 2. So I get the square root of 2 subtract a negative 2 plus 3, and I want to see if that's going to equal negative 2 plus 7. So where I saw the variable x, I substituted negative 2. Well, 2 subtract negative 2 is 4, because it's 2 plus 2, which is 4. So that becomes the square root of 4 plus 3. And I want to see if that's going to equal, and then on this side, negative 2 plus 7 is 5. Well, the square root of 4 is 2, and 2 plus 3 is indeed equal to 5. So the only solution is x equal negative 2. That's your solution. So again, you have to check for extraneous roots. You have to check for extraneous roots. Okay, so sometimes both of them will work, as in the previous problem. Sometimes only one will be a solution. Don't always assume that if your solution is negative here, that it doesn't work, because you notice that this is indeed a solution to the original problem. Oops, sorry, right here, the original problem. Okay, all right, let's look at number 8. Number 8. So number 8, we have this. We have the square root of 19 minus 3x minus 1 equal 3x. So the square root of 19 minus 3x minus 1 equal 3x. So again, we're gonna get the square root by itself. So I'm going to add 1 to both sides. And so when I do that and combine like terms, I'm going to get the square root of 19 minus 3x equal 3x plus 1. All right. Now, once you get the square root by itself, the next step is to square both sides, because you want to get rid of this square root. So you're going to square both sides. So when I square both sides, notice you put both sides in parentheses and then you square it, just like I did. So you don't square each term. Don't make that mistake. That's a common mistake. Don't square each term. You got to square the side. Once you do one side of the equation, you do to the other. And so the square and the square root don't do each other. So all you left with is, on this side, is a radicand. So remember, you want to get rid of the square root, and you did. On this side, though, go off to the side and figure out what this is. 3x plus 1. Don't say that's 9x squared plus 1. That's not true. Remember, when you square a binomial, you're going to get a trinomial. When you square a binomial, you get a trinomial. All right, so FOIL it out. Write it out and then FOIL it. 3x times 3x is 9x squared. The outer is 3x and the inner is 3x. So that's 6x. And the last, 1 times 1 is 1. So this is what you get. So that goes here. So I get 9x squared plus 6x plus 1. All right, now notice this is a quadratic equation, so I'm going to put it in standard form. All right, so I'm just going to go ahead and add 3x first. Notice I'm aligning my like terms. And so I get 19 equal 9x squared plus 9x plus 1. 6x plus 3x is 9x. Then I'm subtract 19 from both sides. Notice I'm aligning my like terms. 19 minus 19 is 0, which is what you wanted, because remember, you want to put it in standard form. Ax squared plus bx plus c equals 0, so you need 0 there. Equal, and this is 9x squared plus 9x, and then this is minus 18. Okay? All right, so Remember, these are going to be factorable. Now, to make things a little bit easier yourself, you see both of these three terms, they have 9 in common, the factor 9. So you could factor out a 9 to make it easier on yourself. Okay, some of you though may not have seen this, so what probably some of you would have done was you would have said, all right, I'm just going to go ahead and factor. All right, it's no big deal, you can still factor. You just not, if the problem said to factor, remember you got to take out the GCF first. All right, so and I'm going to remind you about this, so if one of your problems said factor 9x squared plus 9x minus 18, remember to factor that. If that was just a problem, not an equation, but just a problem, remember the first thing you got to do is factor out the GCF. So the GCF here is 9, so you'd say 9 times x squared plus x minus 2, and then you factor this trinomial. So you would get 9 times, and then, let's see, that'll be x plus 2x minus 1. So that's how you would factor this, okay? But since this is an equation, and if you didn't factor out the GCF, it's really no big deal since this is an equation. Now, it would be a big deal here, but since this is an equation, it's not a big deal. You would just say 3x, just like that. For 18, let's try 9 and 2. Let's see if 9 and 2 would work. 9, 2, no. Let's try 6 and 3. 6 and 3. Let's put the 6 here. 6 here, 3 here. Let's see if that's going to work. That's 18. That's 9. Okay, so 9, 18. That's going to work. All right. So what's going to have to be, remember the larger of these, the outer is 18x, the inner is 9x, and the larger takes the positive term. So that has to be plus, this has to be minus. And so check it though, 3x and 3x is 9x squared, the outer is 18x, the inner is a negative 9x, and so when I add them up I do get positive 9x, and then negative 3 times 6 is a negative 18. All right, now you're going to use the zero factor property, you're going to say h1 equal to 0. Okay, and then you're going to add 3 to both sides, so you're solving this linear equation. And so divide both sides by 3, you get x to be 1. So that's one of your solutions to this quadratic. All right, so remember it may or may not be a solution to the original. So you got to check for extraneous solutions. Over here, you're going to subtract 6. I get 3x equal negative 6. Divide both sides by 3. I get x to be negative 2. All right, so I got to check both of those. So we're going to go back to the original. So let's check x equal 1. So I got the square root of 19 minus 3x. I'm just writing the original equation. So that was the original. So where we see the variable x, I've got to substitute 1. So I got the square root of 19 minus, and then 3 times 1 is 3. 3 times 1 is 3. Minus 1, and I want to see if that's going to equal 3 times 1, which is 3. Okay? So I get 19 minus 3 is 16. So I get the square root of 16 minus 1. And again, I want to see if that's going to equal 3. Well, the square root of 16 is 4. And 4 minus 1 is indeed equal to 3. So x equal 1 is going to be a solution to the square root equation. Now let's check negative 2. So I'm going to check it right here. So let's check x equal negative 2. So I'm going to write the equation over. So here's the equation. Minus 1 equal 3x. So where I see the variable x, I'm going to substitute negative 2. So I get the square root of 19 minus 3 times the negative 2. So here it was easier just to say 3 times 1 is 3 because x is 1. So here actually put the negative 2 in place of x. Minus 1, and I want to see if that's going to equal 3 times negative 2. That's what I'm interested in finding out. Well, this becomes 19. Now when I subtract 3 times negative 2, that becomes 19 minus a negative 6, which is 19 plus 6. and that becomes negative 6 on this side. 19 plus 6 is 25. And we'll see that's going to equal negative 6. 25, the square root of 25 is 5, and 5 minus 1 is 4, which is not 6, not negative 6. Okay? All right. So, so that means that negative 2 is not a solution to the original problem. So negative 2 is an extraneous root. So negative 2 is a solution to this quadratic, but it's not a solution to the original. So that's why you have to check for extraneous solutions. Now, remember how right here when I solved this quadratic equation, I did not factor out the GCF. I just went ahead and I did this, and it didn't matter because I was solving an equation. But let's go ahead and do the same one right here, and let's just factor the GCF. Let's do this properly. So if I took out the GCF, I'm just going right here, I'm going to rewrite this over. So I got 9x squared plus 9x minus 18 equals 0. So some of you would have factored out the GCF. So you get 9 times x squared plus x minus 2 equals 0. That's what you get. And then you would factor this trinomial. So you get 9 times x plus 2 times x minus 1 equals 0. Okay? And then notice there are 3 factors equal to 0. And so you would say, I'm going to set each one equal to 0. I'm going to set each factor equal to 0. Well, the problem is, remember that when you set 9 equal to 0, that doesn't make any sense. So really, when you set those factors equal to 0, you want to set the factors that contain variables. So these right here are the only 2 factors that contain variables. So you set those equal to 0. Because this is never 0. Remember, in order to get 0, one of these factors has to be 0. One of these 3 factors. Well, this is never 0, so don't even use it. Just say either this is 0 or this is 0. And so when I solve for x, here I get x to be negative 2, and here I get x to be 1. And then the rest is negative 2 and 1, which is what we got here. All right. So I mean, we just got to check now. So this would not work, but this one would. Okay. All right. So that is just, now there are other problems that could arise here, other square root equations that you could also look at. But for our lesson, just for this particular lesson, this is going to suffice. So this is going to end this lesson, which dealt with solving square root equations in which we had rational solutions.